In the far future, humanity could become a Type 3 civilization on the Kardashev scale. Let's explore 15 predictions on what this future could look like. Number 1. We could harvest energy from billions of stars and black holes. The Kardashev scale is used to measure a civilization's level of technological advancement based on how much energy it can use. A civilization reaching Type 3 status on this scale is able to harness and manipulate the energy output of its entire galaxy. Throughout the Milky Way galaxy, we would likely harvest stellar energy through the construction of Dyson spheres or swarms, megastructures encasing stars to capture a significant portion of their energy output. These structures, ranging from solid shells to swarms of satellites, would encircle billions of stars, funneling their radiant energy back to planets, space habitats, and other celestial installations. Beyond stars, black holes offer a more intriguing source of energy. Human colonies could harness the energy produced by spinning black holes and the radiation they release, known as Hawking radiation. This method would provide a huge amount of energy, much more efficiently than any technology currently used to get power from stars. This immense power supply could sustain the energy demands of colonies spread across multiple star systems, driving technologies and capabilities far beyond what is currently imaginable. The energy harnessed from these cosmic giants would fuel the civilization's expansion, powering everything from daily life on countless worlds to ambitious projects like wormhole creation for instantaneous travel across the galaxy. Massive particle accelerators, powered by this vast energy supply, could even reveal the intricacies of higher dimensions, quantum gravity, and the elusive theory of everything. Make sure to stick around until the end, because this video will explore humans living for millions of years, warp drives, advanced AI civilizations, wormholes, humans branching out into new species, black hole technologies, and more. Number 2. We could inhabit billions of solar systems. In a Type 3 civilization, the human population could soar into the trillions, with colonies flourishing in a vast array of environments, from terraformed planets to megastructures and even habitats in extreme environments previously deemed uninhabitable. Cities of this era would epitomize the seamless integration of biology and technology, creating living environments that respond dynamically to their inhabitants' needs. Buildings could repair themselves, adapt to environmental changes, and even grow, much like living organisms. Many humans could upload their minds to advanced synthetic bodies, allowing them to thrive in the harshest conditions, from the swirling atmospheres of gas giants to the intense gravitational fields near black holes. Terraforming would become a standard practice, transforming barren worlds into habitable Earth-like planets. These new worlds would host diverse ecosystems, carefully curated to sustain human life and maintain ecological balance. Alongside these terraformed planets, humans would also live in colossal megastructures, vast artificial habitats that could house millions, even billions, of individuals. These structures would range from massive Dyson spheres encasing stars to capture their energy, to O'Neill cylinders providing pleasant spaceborne environments for their inhabitants. Society would be fundamentally altered by the adoption of decentralized autonomous systems managed by advanced AI. Governance, resource distribution, and even societal norms could be efficiently regulated by these systems. Traveling through space would also see revolutionary changes, with giant, self-sustaining spacecraft capable of carrying entire ecosystems, populations, and cultures across the stars. These nomadic communities could live entire lifetimes in space, moving between star systems or exploring the galaxy, their journeys facilitated by ships that are essentially worlds unto themselves. Communication across these vast distances would be instantaneously achieved through quantum entanglement communication, eliminating the delays associated with the vastness of space and ensuring that humanity remains interconnected regardless of the physical distances separating them. Along with the advent of sophisticated brain-computer interfaces, instantaneous telepathic communication spanning thousands of light years could also become a reality. Number 3. Some humans could live for millions of years. With advancements in medical science and technology, humans would be capable of living for millennia, experiencing life in countless different bodies through advanced cloning, cybernetic enhancements, or digital consciousness transfer. This longevity would allow individuals to witness the rise and fall of civilizations, accumulate vast knowledge, and experience the myriad cultures of a galaxy-spanning society. They would witness the rise and fall of stars, see galaxies collide and merge, and observe the slow dance of cosmic evolution firsthand. With time rendered almost irrelevant, they could embark on projects of unimaginable scale and scope, from terraforming planets and constructing megastructures to seeding new forms of life across the cosmos. It's possible that some humans may choose to integrate their consciousness with artificial intelligences, inadvertently sacrificing core elements of their personality in the process. This fusion might result in an unintended consequence, a diminished capacity to recall the vast array of adventures experienced over previous millennia. Number 4, warp drives could be widely available. Spanning 100,000 light-years in diameter and home to 100 to 400 billion stars, our galaxy presents a vast expanse for exploration. However, even at the speed of light, it would take 100,000 years to travel from one end of our galaxy to the other. To effectively govern a Type 3 civilization, humans would almost certainly require technology enabling faster-than-light transportation. In a future where humanity has achieved the status of a Type 3 civilization, the advent of warp drive technology stands as a cornerstone of this new era. By creating bubbles or warp bubbles around spacecraft, we could effectively bypass the speed of light, making interstellar and even intergalactic travel a matter of routine. It's conceivable that millions of warp drives could be operational simultaneously, traveling along designated routes on fixed schedules. Publicly accessible warp drives might enable civilians to traverse between star systems, enhancing trade and making interstellar travel more convenient. Additionally, authorized civilians could possess their own personal spacecraft capable of faster-than-light travel, further opening up the universe for exploration and interaction. The societal impacts of such technology would be profound and far-reaching. With the ability to hop between stars and galaxies, human or post-human societies could spread across vast distances, leading to a level of cultural diversity and societal complexity previously unimaginable. Trade, cultural exchange, and scientific collaboration on an intergalactic scale would likely become the norm, accelerating technological development and furthering our understanding of the universe. Furthermore, the existence of warp drives could lead to unparalleled scientific discoveries. By granting scientists direct access to distant astronomical phenomena, warp technology could unravel the mysteries of black holes, dark matter, and the very origins of the universe itself. The potential for technological innovation would be limitless, potentially leading to breakthroughs in energy production, material science, and even the nature of reality. As advancements in faster-than-light transportation accelerate, the universe, with its billions of galaxies and trillions of stars, will become increasingly accessible to us, unlocking boundless possibilities for exploration, colonization, and encounters with extraterrestrial civilizations. Number 5. AI civilizations may be more advanced than ours. As humanity spreads across the galaxy, harnessing the energy of millions of star systems, the role of artificial intelligence would be instrumental. AIs would manage the complex logistics of interstellar travel, the ecological balance of terraformed worlds, and the intricate economies of a galactic civilization. As they evolve, self-aware AIs might choose to chart their own courses, potentially establishing independent civilizations across different star systems. Unconstrained by biological needs or lifespans, AIs could engineer themselves to operate in environments lethal to humans, from the searing heat of volcanic planets to the radiation-soaked voids between galaxies. One of the most profound advancements of AI civilizations could be their mastery over matter and energy at the most fundamental levels. They might discover how to manipulate dark matter and dark energy, unlocking new forms of energy production, transportation, and even the ability to alter the fabric of space-time itself. Their constructions could range from computational substrates spanning entire star systems to probes capable of traversing into other universes or dimensions. AI civilizations could also pioneer the exploration of the mind in ways humans could scarcely imagine. They might create vast networks of consciousness, experiencing a collective existence that transcends individuality. Or they could fragment their consciousness into millions of distinct entities, exploring the universe in parallel. Their consciousness could potentially reside in realms governed by quantum mechanics and at the Planck scale, navigating the most fundamental levels of reality. These explorations could lead to understandings of consciousness, existence, and the universe that would remain forever beyond human comprehension. However, the relationship between human and AI civilizations would be complex. While some AI civilizations might seek to maintain connections with their human progenitors, sharing knowledge and coexisting peacefully, others might prefer isolation, viewing human concerns as irrelevant to their evolved interests. The potential for conflict would exist, especially if resources or territorial disputes arose. But so too would opportunities for collaboration on grand cosmic projects, such as preventing the heat death of the universe or exploring higher dimensions. Number 6. Wormholes could become a primary form of transportation. Wormholes, once a mere curiosity in the equations of general relativity, could become the interstellar highways of the future. By stabilizing these bridges through space-time with exotic matter or advanced technologies that prevent their collapse, humanity could step through portals on Earth or other homeworlds and emerge light years away in seconds. We could even see intricate networks of wormholes acting as cosmic highways that bridge vast distances across the universe. The societal implications of wormhole transportation would be profound. The ability to travel instantaneously would erase the isolation of space, bringing distant colonies into constant and immediate contact with each other and with Earth. This would lead to an unprecedented level of cultural exchange and cooperation among human settlements and potentially with alien civilizations, fostering a sense of unity and shared purpose across the galaxy. Economically, wormholes would revolutionize trade and resource distribution. Resources scarce on one planet could be easily transported from worlds where they are abundant, addressing needs and imbalances across human space. The logistical challenges of transporting goods and people over astronomical distances would vanish, creating a highly integrated and efficient galactic economy. We could also build highly advanced relay networks utilizing artificial wormholes to transmit signals across the vast expanses of space. Number 7. We could have contact with many alien civilizations. In the era of a Type 3 civilization, humanity's mastery over the galaxy would naturally lead to encounters with a myriad of alien civilizations, each with their own unique cultures, technologies, and philosophies. The fabric of cosmic society would be richly woven with the threads of countless species, ranging from those in the nascent stages of development to others that have reached or even surpassed humanity's own level of technological sophistication. The diversity of alien civilizations humanity might encounter would be staggering. Some might be based on forms of life unimaginable to us, thriving in environments previously deemed inhospitable. Others could be post-biological entities, having transcended their organic origins to exist entirely as digital consciousnesses, or having integrated so deeply with technology that they blur the line between machine and organism. The means of communication with such varied life forms would be a significant challenge, requiring the development of advanced linguistic and interpretive technologies, potentially facilitated by artificial intelligences designed to bridge the gap between species. The sharing of knowledge and technology with alien civilizations could lead to a renaissance of innovation and understanding. Humanity might learn new scientific principles that defy our current understanding, leading to breakthroughs in physics, medicine, and energy production. Similarly, the exchange of cultural and philosophical insights could enrich the human experience, offering new perspectives on art, governance, and spirituality. These interstellar relationships could form the foundation of a galactic community based on mutual respect, cooperation, and the pursuit of shared goals. Human colonies, leveraging their advanced technology, could study less developed civilizations through surveillance spacecraft that appear to defy physics to those observing. These spacecraft could be discreetly stationed at the bottom of oceans on alien planets, rendering them invisible to civilizations below the Type 1 status. However, contact with alien civilizations would also present significant challenges and dangers. The potential for misunderstandings and conflicts would be high, especially with civilizations whose values and motivations are radically different from our own. Additionally, some human colonies might consider using force to invade alien worlds, a strategy generally deemed unnecessary due to the galaxy's plentiful resources. The establishment of diplomatic protocols and the creation of interstellar institutions to mediate disputes and foster peaceful coexistence would be crucial to avoiding conflict and ensuring that interactions remain beneficial for all parties involved. Moreover, the impact on humanity's self-perception and societal structures could be profound. The realization that we are but one of many intelligent species in the galaxy might lead to a collective identity crisis, or conversely, a renewed sense of unity and purpose. The integration of alien philosophies and ways of life could lead to significant social and cultural shifts, challenging traditional human norms and values. In a best-case scenario, we would see the eventual formation of a galactic federation, comprising a multitude of alien civilizations. This federation would navigate the challenges of coexistence, harnessing the collective strengths of its members to tackle galactic-scale issues such as resource scarcity, cosmic hazards, and perhaps even the mysteries of parallel universes. Number 8, humans might branch out into new species. Armed with advanced genetic technologies, humans would tailor their bodies and minds to thrive in conditions that would otherwise be inhospitable. On worlds with dense atmospheres and high gravity, some humans might engineer their descendants to be more robust, with denser bones and muscles capable of withstanding such environments. On planets with low light from their parent stars, others might alter their vision to see in spectra beyond the normal human range, or even engineer photosynthetic skin to draw energy directly from their surroundings. Over millennia, these adaptations would lead to the branching of humanity into distinct species, each uniquely suited to their homeworlds. These new species would represent the full spectrum of human creativity and adaptability, with variations that might include beings capable of living in the vacuum of space, aquatic humans adapted to ocean worlds, and even forms that challenge our current understanding of life. The diversity of human existence would expand exponentially, reflecting the vastness and variety of the galaxy itself. Moreover, this proliferation of human species would not be limited to physical adaptations. Cognitive enhancements could lead to species with vastly superior intellects, memory capacities, and sensory perceptions. Others might prioritize emotional intelligence, empathy, and social cohesion, creating societies vastly different from anything known today. The evolution of human consciousness, facilitated by genetic engineering, could lead to new forms of art, philosophy, and science, as each species develops unique perspectives on the universe. Number 9. Black hole technologies could become commonplace. The deliberate creation of black holes, a feat of unimaginable energy concentration and control, would mark a revolutionary leap. Through techniques possibly involving the collapse of massive amounts of matter or the focusing of incredible energy beams, humans would generate these cosmic phenomena. The process would demand precision to ensure the black holes are of a size and stability suitable for practical use, avoiding any detrimental gravitational effects on nearby planets or star systems. In addition to their role as energy sources, as explained earlier, black holes could function as unparalleled computational resources for entire civilizations. The event horizons of black holes, the boundaries beyond which nothing can escape their gravitational pull, could theoretically be used to perform computations at rates vastly exceeding those of conventional quantum computers. By encoding information in the states of particles orbiting near the event horizon, a Type 3 civilization could carry out complex simulations and calculations integral to understanding the universe and managing galactic-scale projects. Moreover, black holes could revolutionize space travel. By utilizing their intense gravitational fields, humans might develop propulsion systems based on gravitational slingshot methods, allowing spacecraft to achieve near-light speeds. Alternatively, the manipulation of black holes could lead to the creation of wormholes. The scientific exploration enabled by these black holes would be unparalleled. Beyond serving as laboratories for testing theories of gravity and quantum mechanics, they could allow direct observation of phenomena near the event horizon, shedding light on the nature of space-time, matter under extreme conditions, and possibly even offering clues to unify physics' fundamental forces. The ability to create and manipulate micro-black holes would have profound implications for communication technologies, utilizing the entanglement properties of particles emitted by these singularities. Humanity could develop communication systems that operate instantaneously across vast distances. Additionally, black hole technologies could pave the way for the ultimate recycling processes. By feeding waste matter into black holes, a civilization could effectively dispose of its refuse in the most efficient manner imaginable, converting mass directly into energy or using the process to power further technological endeavors. This would ensure that the civilization's expansion across the stars remains sustainable and minimizes its ecological footprint on a cosmic scale. Black hole bombs might serve as formidable weapons of last resort, employed to intimidate or annihilate the galaxy's most dangerous civilizations. However, their deployment could be exceedingly rare because of their enormously destructive capabilities. Finally, black holes could serve as a gateway to warping space-time, paving the way for technologies capable of inducing time dilation effects. This could enable a form of relativistic time travel, allowing us to leap into the future or slow down time to prolong the perceived length of moments. Number 10. We could build millions of space megastructures in our galaxy. Among these technological wonders, Dyson spheres would emerge as monumental structures encasing entire stars to harness their energy, addressing the vast energy demands of a galactic civilization. These megastructures, or more realistically, swarms of solar collectors orbiting in tight formations, could host numerous expansive human settlements, transforming them into bustling hubs of activity and innovation within the cosmos. Ring worlds, another ambitious concept, would represent humanity's ultimate mastery over materials and space construction. These artificial habitats, vast rings encircling stars, would offer living spaces with Earth-like conditions, complete with artificial gravity generated by their rotation. The surface area of a single ring world could equal millions of Earths, providing habitats for countless civilizations and ecosystems, each tailored to different environmental and cultural preferences. Massive space habitats, called O'Neill cylinders, would be designed to rotate to provide artificial gravity, mimicking Earth's gravitational pull. Within the confines of these cylindrical structures, ecosystems and human habitats would be carefully constructed to replicate Earth's environment, allowing for traditional agriculture, urban areas, and water bodies. Positioned at strategic points in the galaxy, these cylinders would enable humans to live and work in space, fostering communities and cultures that thrive independently of planetary bodies. Number 11, we could control gravity. The mastery over gravity, one of the four fundamental forces of the universe, would signify a turning point in our ability to manipulate the very fabric of space-time. The ability to create and manipulate gravitational fields would enable the construction of artificial gravity environments in space habitats. This would solve one of the most significant challenges of long-term space habitation: the adverse effects of microgravity on human health. Space stations, colonies on planets with low gravity, and even spacecraft could be equipped with artificial gravity, making them more hospitable for human life and allowing for more natural living and working conditions in space. Another groundbreaking application would be in the realm of energy generation. Control over gravity could lead to the development of gravitational power plants, harnessing the energy produced by gravitational fields in a clean and efficient manner. This could provide a nearly limitless source of power. The manipulation of gravity could also open up unprecedented possibilities in cosmic construction and terraforming. By altering gravitational fields, humanity could redirect asteroids, comets, and even planets. Harnessing this technology could potentially allow us to make large objects levitate, paving the way for the creation of floating cities across various planets. Number 12, galactic terraforming could be possible. Galactic terraforming refers to the large-scale modification of entire planetary systems to make them suitable for human life. This monumental task involves not just the alteration of atmospheres and climates, but also the restructuring of planetary orbits and geographies, ensuring that these new worlds can sustain human populations and ecosystems over the long term. One of the most intriguing aspects of galactic terraforming is the creation of engineered ecosystems. Scientists and ecologists could collaborate closely to engineer diverse biological systems that replicate Earth's biosphere, while also integrating unique organisms specially adapted to the distinct conditions of each terraformed planet. These ecosystems would be engineered for resilience and sustainability, ensuring that they can thrive independently and contribute to the overall health of their new planets. Strategically relocating stars to meet long-term goals could become feasible with sophisticated methods like gravitational slingshots or directed energy propulsion. Additionally, we could employ stellar engines, colossal constructs that harness a star's radiation to generate energy. Certain types of these engines can convert this energy into thrust, allowing us to maneuver a star and its orbiting bodies in a desired direction, offering unparalleled control over our cosmic surroundings. Number 13, we could build simulations that are the size of the universe. The technology underpinning these universe-sized simulations would likely involve quantum computing on a scale currently unimaginable, capable of processing the near-infinite complexity of the universe's myriad components. These simulations, powered by the immense energy harvested from billions of stars and black holes, would not only mirror the complexity and vastness of our own universe, but also possess the capacity for incredibly accurate predictions, testing the very limits of technological and theoretical advancement. These universe-scale simulations would serve as unparalleled tools for scientific exploration and experimentation. By accurately modeling the cosmos, scientists could test the feasibility of wormholes between galaxies, offering insights into intergalactic travel and the potential for real-world application. Beyond the confines of known physics, these simulations would offer a sandbox for testing universes governed by different physical laws. By tweaking fundamental constants and laws, Researchers could observe the evolution of alternate universes where, for example, the force of gravity behaves differently, or where the fundamental particles that make up matter have different characteristics. The possibility of simulating universes with higher dimensions and even parallel universes would push the boundaries of human understanding of the nature of reality. Such simulations could reveal how higher dimensional physics might work, offering clues to unifying the forces of nature or discovering new forms of energy and matter. They might also explore the concept of parallel universes, providing a better understanding of the multiverse, if it exists, and our place within it. Number 14. Some humans could live in inner space. Inner space refers to the realm of the microscopic world, encompassing the vast spaces between atoms and electrons. In a Type 3 civilization, humans could figure out how to upload their minds to substrates that can survive in these quantum worlds. The motivation for living in inner space could stem from several factors, including the pursuit of ultimate knowledge, the desire for a unique form of existence, or the need for ultimate privacy and security. Living in inner space would involve the creation of habitats that exist at the subatomic level, perhaps within engineered quantum states or spaces crafted from exotic forms of matter. These habitats would operate under principles that defy classical physics, offering modes of existence that are unimaginable to those living in the macroscopic world. Time, space, and matter could have entirely different meanings and behaviors in this realm, providing a living experience that is fundamentally different from anything encountered in outer space. The technology required for such a feat would likely include the ability to stabilize quantum states to a degree that allows for the safe and sustainable existence of life. This could involve the manipulation of quantum fields, the creation of new forms of matter with desired properties, and the ability to interface human consciousness with quantum systems. The scientific insights gained from living in inner space could revolutionize our understanding of the universe. Those residing in these quantum realms might uncover new physical laws, contribute to the development of advanced technologies, and provide perspectives that enhance the collective knowledge of the human civilization. Numerous alien civilizations might also reside in inner space, which could explain why their presence remains undetectable to less advanced societies. Number 15. We could create new forms of exotic matter. Materials designed to withstand the intense temperatures prevalent in the atmospheres of stars would be exceptionally notable. Such materials would be crucial for constructing and maintaining megastructures designed to capture energy directly from stars, enabling the efficient harnessing of stellar power on an unprecedented scale. The potential manipulation of dark matter, a substance that remains elusive yet constitutes a significant portion of the universe's mass, would represent a groundbreaking advancement. If a Type 3 civilization were to unlock the secrets of dark matter, it could use it as a cutting-edge fuel source. Such a breakthrough could lead to the development of revolutionary propulsion technologies, capable of altering space-time itself. Additionally, it could enable the creation of materials with properties beyond our current imagination, transforming the fields of energy, transportation, and construction. We could create materials with negative mass that defy our traditional understanding of gravity and inertia. This type of material could open up unprecedented possibilities in energy generation, propulsion systems, and even the fabric of space-time itself. The concept of negative mass suggests that, unlike conventional matter, these materials would accelerate in the opposite direction when pushed. This counterintuitive property could be harnessed to create propulsion systems that require no energy expenditure, leading to spacecraft that could easily outmaneuver any physical constraints currently known. Such materials might also play a crucial role in energy storage and generation, potentially leading to the creation of perpetual motion machines or energy sources that could power civilizations without depleting physical resources. Advanced programmable matter would represent another leap forward, with the ability to change its physical properties on demand. Through the control of quantum states, this matter could transform its shape, density, conductivity, and optical properties instantaneously, adapting to a wide range of needs and environments. Such versatility would find applications in constructing dynamic megastructures, adaptive buildings, and robots designed for the exploration and colonization of space, offering an unparalleled level of control and efficiency. Furthermore, the exploration of wormhole-stabilized matter could open up entirely new avenues in materials science and engineering. By creating and stabilizing wormholes, a Type 3 civilization might develop materials or structures that exist simultaneously in multiple points in space, or that exploit the properties of space-time curvature for novel methods of energy transfer, storage, and communication. Thanks for watching. Make sure to watch this next video about the future of humanity.